So we're told that these boxes in a warehouse were arranged in stacks of 8. There are 4 boxes left. So let's say if the total number of boxes were n, and if there were, let's say, Q1 stacks, I'm kind of using that relationship with the remainder theorem, but you can use any variable here. So that's the total number of boxes. And this is the number of stacks of 8. And they also tell us that n is greater than 80 and less than 180. Question is, what's n? So we'll see what we can do with the statements. Statement 1 says if all the boxes in the warehouse had been arranged in stacks of 9, there would be no boxes left. So n is a multiple of 9, so some other integer q2. So one easy way is, because we're given a range for n, we can list the numbers that are multiple of 9. So that would be 81, 90, and I'm looking for numbers that fall in that range. 99, 108, and then the next one would be 121. No, actually, next would be 117. So that also falls here. And then we go beyond that, which would be 126. So these are the 5 values based on statement 1 that satisfy this condition. Then I can see which one of these would satisfy this condition, meaning if I divide this by 8, remainder should be 4. This one gives me a remainder of 1. That one gives me a remainder of 2. 8 times 1 is 8. Yeah. This one gives me 8 times 1 is 8. 1. 8 times 2 is 16. That's going to give me 3. 2. 8 times 3 is 24. So 13 times 8 is 104. So remainder of 4. So 108 satisfies that condition. And if we look at this 117, 8 times 4 is 32. That's going to give me a remainder of 5. And you'll see how the remainders are going 1, 2, 3, 4, 5. So there's only one value. So if with statement 1 alone, it's sufficient, meaning to satisfy both statement 1 and the information given in the main stem, n must be 108. So 1 alone is sufficient. 2 says if they're arranged in stacks of 12, there would have been no boxes left over. So that means n is a multiple of 12. So again, I can list numbers that are multiples of 12. The least one is 84. 12 times 7 is 84. Then 96. And then 108. And I can see what happens if I divide this by 8, because I have to also satisfy that condition. This gives me a remainder of 4. This gives me a remainder of 0. And that, as we already know, also gives me a remainder of 4. So with statement 2 alone, n could either be 84 or 108. So we don't have a unique value. 2 alone is insufficient. Answer is A.